Hello, everyone. Welcome to live session number 4. Thank you so much for joining us again today. This is our live and final session before the hackathon launches in very few days. So far, we've had some really great presentations from both the jury members and the mentor and coach team. We've heard all about the Blue Cloud resources. We've had some pretty great speeches about why the ocean matters, as well as ocean best practices. And today, during this session, we are going to introduce you to your lead mentors for each challenge, and we're going to dive in a little bit deeper to the challenges themselves. So we have a very good lineup again. We are just going to begin again with our house rules, which once again are that we're going to be recording the session, as you know, and we're going to put it online after this session as a resource. You can submit all of your questions through the Q&A button. We're going to answer all of them either during the session itself, if it's a question that can be answered during this, or we're going to address them at the end of the session. Additionally, any further questions that we do not have time to answer live here, please put them in the Discord channel. So we are going to start. We're going to get directly into challenge 1. I don't know if you can, okay, thank you, you can still hear me. So we're going to go to Jean-Olivier and his team for challenge 1. Thank you, Jean-Olivier. If you, yes, thank you.
Yeah. Hello, everyone. Let me just share my screen. Oh, just sorry. I'm not sure I shared with the sound. I made the mistake yesterday. Yes. Okay, here we go. So welcome everyone. Challenge 1 is about mapping and understanding ecosystems and species within these ecosystems. And the overall motivation of this is that if we look at observations of biology in the ocean, they're pretty scarce. So you see this is a map of observations of plankton. There's quite a few points, but still there's entire areas of the world's oceans that are empty. To understand it better and inform decision-making in a good way, we usually need complete coverage like the nice rotating map that you have underneath. And one way to go from this, from the first to the last one, is habitat suitability modeling or species distribution modeling or niche modeling. That's different terms for somewhat the same thing. And so the goal of challenge 1 would be typically this, to go from scarce observation to global coverage through these type of models. But that can be for different purposes. It could be extrapolate the distribution of a single species or of biodiversity. The rotating map here is a biodiversity of plankton, for example. But you could also extrapolate functions of ecosystems, so from genes, for example, or even traits like size, at global scale. And finally, the data we have is geared towards plankton, but actually you could also correlate this with higher trophic levels such as fisheries. But overall, I mean, it's your hackathon, so you'll do what you want to do, but the challenge and the tools we provide are geared toward this. So these tools are the ones that are within the Blue Cloud ecosystem. The first and main one is the ecosystem workbench, which was presented yesterday, which allows you to query existing databases, of various kinds, and then use Cephalopod to do the extrapolation. There's also a VLab from a previous version of Blue Cloud that gives you access to genomic information in a finer way than Cephalopod does. There's, again, from the previous version of Blue Cloud, there's the zoo and phytoplankton VLab that gives similar output to which you can compare and contrast what you would get for zoo and phytoplankton. Similarly, you have a great resource for fisheries in the form of the Global Tuna Atlas, for example, that can either provide data or be a benchmark to compare against. And finally, there's a wealth of data of point data in a data discovery and access service that you can query as a substrate or the initial data set for the extrapolation that you would do afterwards. So in the following, what we'll do is show you a few of these tools and focusing on getting data that you would then be able to extrapolate with the tools that were presented yesterday. And the first one is how to use cephalopods, the same tool as yesterday, to query data occurrences from OBIS. And this is a movie which hopefully you will be able to hear.
Hi everyone, I will show you how to query occurrence or abundance data in OBIS or Atlantico using the cephalopod pipeline. So here I'm in the master script of cephalopod. So after running the first lines of the code to load libraries and to provide the run name, I will execute the list bio wrapper function to list all the available species in OBIS because I use the occurrence input as data source. But you can do exactly the same with abundance to list available species in Atlantico. So, for instance, if I want to query occurrence data for Calanus finmarchicus, I just have to check that this species is actually available in list bio, which is the case. So after that, I can run the run init function to create the output folder for my species here, in which I will find the query or objects in which I will find occurrence data or abundance data. For that, I just have to run those lines to query occurrence for this specific species or to query abundance for this species. Then I will find in the query or object measurement value, which correspond to occurrence when you query occurrence, and all the other information such as location, measurement units, and year, depth, etc.
Okay, so this is to show that with cephalopod, you will be able to do the extrapolation, but you can also actually query dynamically data in OBIS, GBIF, and Atlantico. You don't need to query it yourself and then go to cephalopod. Okay, the next one is about using the Plankton Genomics VLab to extract metagenomic information, and it will be presented by Alexandre.
Hi there, Alex again for some video on how to use cephalopod, and this time how to use the Plankton Genomic VLab to get enzymes that encode for functions performed by microbial plankton, such as photosynthesis, nitrogen fixation, beta-carotene production, whatever you fancy. Here I am in the Plankton Genomic VLab. There is a zip file here that you need to copy. So you can access it here. You open Jupyter Hub. Here I'm in my home directory. That's the zip file, and that's unzipped. Here I have data function code like for cephalopods. And what you want to interact with is the service1 Python notebook. So here you have all the documentation that's embedded in the notebook as well. Like this you won't need for the challenge, or at least for using cephalopod, as you have environmental data in cephalopod as well. Short description of the genomic data. Please check the KEGG website to understand and get the identifiers of the enzymes of interest that you would like to model. Please read this service description. That's the different folders. It's roughly the same as cephalopod, but in an older version. Here you have package installation that should already be done. This block cleans your your memory of the Jupyter instance. Set the working directory, load all the packages, define the model parameters if you want to model it using the Plankton Genomic VLab, source all the functions, and that's the interesting part. Here you query the data. And that's your identifiers of functions or enzymes that encode for a function. And here you query the data that you need for that. So you can run it until here, and then you have the big query object that is here. So you have all the information about functional clusters, where they are, how much, and so on. And the idea is that you can get this object, paste it into R in a custom code, and then reformat it so that it matches the cephalopod CSV file. So that's a way to get functional data into cephalopods. Again, the CSV template for cephalopod is roughly the same as here. So time, location, what it is, how much, what's the unit, and an identifier. Please read the template, and I let you with other examples on abundance and biomass data.
Okay, so that's it for, so we've seen that you can get, again, occurrence or abundance. You can also get functions through genes that encode for enzymes for these functions. And the final thing that you might want to interpolate at global scale are traits. So again, geared towards plankton, because that's our expertise, but you could do this with fish or with whatever else you fancy. So for plankton, there's good resources for traits online. There's the zooplankton traits database that documents traits for a large number of planktonic species. And so if you have the species occurrence and you have the trait, you can do something on traits. There's the PSSDB, which is a particle size spectrum database that documents the size spectrum of particles, but also organisms at global scale, and regrid them so you have a nicely formatted input for habitat suitability modeling. And finally, there's one of the blue data infrastructure, which is Ecotaxa, which contains 600 something million images that often are individually measured, so from which you can get individual measurements of size, length, elongation, ratio, etc., etc. And so in the last slide, I'm going to document how you can query Ecotaxa to extract that information. But I'll start with the last line saying that some of that information is actually already queryable through the data discovery and access service. That concerns a few data sets that are open and published on OBIS and GBIF. But if you want to tackle the whole database or the larger part of the database of Ecotaxa, you need an account on Ecotaxa, okay? Then we've created two packages, one in R, one in Python, to query the API of Ecotaxa, which is documented here, okay? So you can write the queries yourself, or you can use those packages to query. And so the first thing you need to do is log in. This is the R code to log in, just for your email password, and then you get a token, you save it so that it's available for future queries. Then you need to find projects. So projects are essentially data sets. And so Ecotaxa has a list of projects, the ones that in which you're registered, and this one is all the projects that are available. And you should target projects that are marked as open, because this data you can query with no limit. Okay. And then what you might want typically to do is, let's say, to extract the size of a given taxon. So you need the identifier of that taxon. So in that case, I'm searching for Ketognats, okay? And this will answer with the numeric identifier of Ketognats. And then what I will do, so I have a project. I have the project identifier, sorry, I have the species identifier. And then I will get my query. So I give it my project identifier. I give it the filters that I want to apply, which is I want taxon 11,514, which is Ketognats, okay? And all the children of, so Ketognats of any sorts. And then what I want to extract for all of those is the latitude, the longitude, the area, which is a measure of the size, and the major axis length, which is a measure of the length of the organism. I do that query, and then I get an object in which, in the details part, which is a matrix, I get all these 4 fields, okay? I could have extracted the dates, I could have extracted other measurements, okay? And typically this would need to be reformatted, just as Alex just explained. to the input format of cephalopod, but it's actually already pretty close to that input format. Okay, so this way you could extrapolate again size or length of many organisms at global scale. And with this, I leave you and wish you good luck for the hackathon.
Thank you. Thank you very much, Jean-Olivier, and all the team, Alexandre, Virginie, Victoria, for creating all of these great assets. Once again, Jean-Olivier is going to be your lead mentor for challenge number 1. If you choose to take on mapping and understanding of marine ecosystems and species, we're going to be opening the channels tomorrow. So your team is going to start being available then. And any questions you may have, again, you can place here in the Q&A, or we're going to be answering them also on Discord. Thank you very much, Jean-Olivier, once again, for all the input you've provided. And now we're going to move to our colleague, Cyrielle Delvene from VLIZ, who is going to be the lead mentor for challenge number 2, supporting early warning and response to accidents. Thank you, Cyrielle.
Thank you, Angeliki. Can you see my screen?
Not yet.
Not yet. Yes, great. All right, thank you very much. Good afternoon, all. It's great to see you here. I'm very excited to present you Challenge 2, which is about supporting early warning and response to accidents or natural events. So I'll be the lead of this challenge, although I'm definitely going to be supported by all the VLAB 1 experts. So that's people from Portugal, from Mallorca, from a lot of different places with different expertise. And we're all very happy to see what creative ideas you come up with. So here during this presentation, I'll just give you some of my suggestions of what I think this challenge can include. But obviously, you're more than welcome to come up with your own challenge as well, or with very different ideas. So I'll just share kind of some of my personal experience I've had with, for example, invasive species, because that's one of the natural events that's happening at the moment in the world due to tons of reasons, including climate change. And here you can see a picture of a lionfish, which is one of the many invasive species of the Mediterranean Sea, but also many other seas as well. For example, that picture was taken in the Caribbean. And invasive species are changing the ocean, while the ocean itself is also in big changes. So I think this challenge is very interesting because you can definitely link a lot of different economical or any kind of natural events. But of course, there's not only invasive species that we can talk about, but also oil spills or any other chemicals that we find in the ocean. And the current challenges are also that there's not that much information about these challenges or not the right information. So people don't always understand what's actually going on and how it can spread so easily along the coast. And that's what we want you to tackle in this challenge. What solutions can you provide for this? And of course, if you use Blue Cloud and all the work that we have done, you can come up with very good solutions, I'm sure. So what we want you to do is really to work collaboratively to predict those risks and to ensure a swift response to accidents at sea, including, as I said, oil spills, invasive species, and many others. Species are moving, but we need to understand better the way that they're moving, the way that they're feeding, and the way that they live in general. And species migration can have a huge impact on human livelihoods because we rely on fisheries, of course, as a source of protein, but also any type of activities at sea are impacted by these as well. So what we're looking for this challenge and what the judging criteria will be creativity. We also want to see what's the impact of the solution that you will come up with. So if you come up with a very local solution, what's the impact for the local population, or is it global? Why would it be good, and would it be feasible? And what technical implementation would you need? The available resources for this challenge are, of course, any VLABs, any workbench. This one is based on the coastal observations along European margins, which is using Copernicus Marine Service and limited resources. They are both available through the DDAS access service, but you can also link it to any other VLAB, and that's entirely up to you. So some of the ideas that you could use as inspiration are, again, just ideas. You don't have to do these. And if you want to discuss these ideas as well, I'm available on Discord or by email. But the first one that we thought with the experience, and we actually just had a talk just before this meeting, is that you can look for places where boats tend to have oil spills or where they change their ballast waters. And then you can kind of measure with the passive tracker. If you looked at the previous presentation from VLab 1, they explained all the tools that they're providing, can really track how this either oil, if it's for oil spills, or from ballast water, any kind of biological invasive species or others is migrating or is moving along the coast. And it can be going to either an offshore aquaculture farm or an MPA, and then you can see what's the impact of that in that area and really measure how long it will take for them to get there and what would be the impact once it's inside the MPA, or how it will impact the native species, etc. If you need ideas about current challenges, you can always look at what's happening in Turkey. For example, they have a lot of invasive species that are coming and going through Turkey. There's a lot of diving clubs that are recording all of these species. So if you want to help them better measure why they're going through that part of the sea and where they're going after, feel free to reach out. I can always share more ideas. But we also thought about any kind of solutions that you could come up with for the impact of invasive species on offshore aquaculture farms. Either you choose one or many, that's up to you. It could also be on MPAs, so on marine protected areas. You can also suggest solutions to assess the impact of oil spills on marine protected areas or on the coast itself, and suggest solutions to assess the impact of extreme events on offshore aquaculture farm. You can do that using thematic service 2 of VLab 1. If you don't know what I'm talking about, go back to the previous presentation we had on VLab 1. They explain everything about these tools. And then the last one is just to better understand the regional ocean circulation and how it will change either with increasing temperature or with certain changes. Some places are installing new ports in some areas. For example, in the Caribbean Sea, there's a lot of projects for new big ports for ferries on very small islands, so that will have a huge impact on local ecosystems, on local currents, etc. So you can also use this VLab to kind of better understand how these changes would impact either ecosystems or other. And you can also use thematic service 3 of VLab 1 for everything that's glider derived ocean indicators. So the main message I really wanted to share during this quick presentation was, please think out of the box. There's so many different ways that you can tackle this challenge. It's a huge challenge. It can be interpreted in many ways, but it can also save life, because being able to better respond to these kind of accidents can really change a lot for a lot of people, because these accidents, once they happen very quickly. So you have the potential to make a really good impact if you take this seriously. And this hackathon is just the perfect way to work together to innovate for a safer world. So thank you very much for your attention, and let me know if you have any questions. Thank you.
Thank you so much, Cyrielle. This is indeed part of these live sessions, suggesting ideas, but also inspiring participants towards their chosen challenge. It is a very important topic. As we see, climate change has been creating more and more incidents. So we do hope to see some really good solutions coming out. And Cyrielle Delvene is going to be your lead mentor for those of you taking on Challenge 2. you're going to start being able to reach out to her very soon on the Discord channel. Thank you very much, Cyrielle, for the presentation. We are now going to move into challenge number 3 with our colleague Simona, Simoncelli. Thank you very much for being with us. Simona, challenge 3 is about tracking and forecasting ocean health. Again, great topic. A lot of you have signed up for it, and Simona is going to be your lead mentor. Over to you, Simona.
Hello, everybody. I'm really glad to be here. So I hope I'm gonna inspire you to tackle this challenge 3, which is about tracking and forecasting the ocean health. So my objective is to demonstrate you the value of open, collaborative, and multidisciplinary data-driven science to advance ocean knowledge and to tackle the societal challenge of protecting and restoring the ocean health. So first, what I was looking for was the definition of ocean health that we can, let's say, assume as the integrity of the ocean ecosystem. So actually, the ocean supplies us with essentially resources, but it is also a platform for transportation, for trading, and it plays also a crucial role in securing human health and well-being. So it's a lot, it's very important, the relationship that humanity has with the ocean from many different aspects. And what happens today is that basic ecosystem functions are at risk because we are constantly increasing our anthropic pressure on the marine environment. Some examples are overfishing, eutrophication, gas emission, and this is, of course, bringing ocean warming and acidification. So actually, looking at the Agenda 2020, the United Nations, and Global Sustainable Development Goal 14, Life Below Water, and looking at the Decade Ocean Science for Sustainable Development, there are some key elements on the protection and the restoration of the ocean health. So we should conserve and sustainably use the ocean. We should manage and protect the marine and coastal ecosystem to avoid a significant adverse impact, and we should strengthen the resilience and taking action for the restoration of the ecosystem. But we need also to increase our scientific knowledge to implement adaptation strategies, and also we need to develop science-informed policies, responses to global change. So actually, the definition of ocean health is quite generic. What we need is a clear ocean health concept to develop an operational ocean health framework. And through the Marine Strategy Framework the Directive, we have this concept of the good environmental status that is considering resilience, productivity, and diversity, the essential requirement for an integrated assessment of the marine systems. So what are the key elements that are suggested by the paper that I mentioned here in my slide, Franke et al. 2020? So actually, we need to advocate for a truly transdisciplinary and cross-sector research approach that might integrate different disciplines, the natural one with the social sciences, but also to involve all the players that interact with the ocean. We need, of course, regular and thorough monitoring and evaluation of the ocean, especially through long-term data time series of essential ocean variables. We need also tools for integrating data from different environmental and ecosystem components. So how can we assess, secure and improve ocean health? Well, we need also to further develop the model, software, statistical tools, and we need to advance methods like artificial intelligence and machine learning for analysis of the marine data. And we need to adopt transparent, open access ocean monitoring and assessment tools. And so actually this is a schematic that is, in my opinion, summarizing what I just mentioned, which is the marine data value chain or knowledge, ocean knowledge value chain, which starts, gathering data from the ocean, and these data, well, the data gathering should follow the best practices available from the community in order to get the best data. The data then must be managed accordingly to the FAIR principles. So data are then findable, accessible, interoperable, and reusable. And those data can be shared through Blue Data infrastructure, actually must be shared for advantage of the entire society, to be then distributed by this Blue Data infrastructure, which also they can assemble different data, different types of instruments, data, and they can provide integrated and aggregated data sets to derive key products on which we can base ocean monitoring or ocean climate indicators. We can derive ocean assessment reports, and this is going to help early warning system, but also informed decision-making and prior planning. So actually, this is this, let's say, a framework can be based on the concept of the digital ecosystem that the data and information strategy of the ocean decade have defined, which is the digital ecosystems, which is a network of data system that can co-create a distributed, robust, and collaborative digital system to be actively used for decision-making and support sustainable ocean management. So this ecosystem is composed is made by three main components. Of course, the ocean observation and data collection, then the data management and sharing, and the data analytics, modeling, and prediction. So these are the key components, and here are the strategic objectives that have been drafted in this strategy. And I highlighted some of them, which are very important to me, which is on one side, the equitable access to multidisciplinary data, information, and knowledge by all. So it's a kind of democratization of science where as many people as possible can access data to derive information and knowledge. But the second objective is to improve data and information discovery and usability. So we need to implement innovative solution and technical solution to share fair data through fair services. So actually all digital assets should become fair, and we should adopt the open science principle to be able to use the data rapidly. Then another fundamental objective that I have to mention is to build trust in data and information. So it is very important to timely sustain the global flow of well-documented metadata and qualified and ready-to-use data. So it is very important that you pay attention on the data that you use that are very well documented and they are high quality. And these actually are the foundation of traceability, replicability, transparency of the scientific process. So what about tracking and forecasting the ocean health? So we can track and forecast the ocean health using models which are then integrated by observation that can be in situ observation, remote observation, that can be assimilated into models to have prediction and create data output products on which we can implement application and services for society. So now we have also to consider artificial intelligence and machine learning as, new innovative tools, data-driven. So we should pay attention again to the quality of the data that we use to train these models in order to get reliable results. But this model can be used to simulate the past through reanalysis. We can have forecast in the present, so for short term, but we can also implement future projections, and also build some what if scenarios. So we can do it implementing cloud-based workflows. So we can chain tools which can be deployed on virtual environments to complete a task. So the automation of these workflows can create efficient processes, and they can be replicated, and the results are optimized. Again, I stress on the FAIR principle and the advanced services that are necessary on these cloud environments for data access, for software development in a collaborative approach, and the interactive computing. So these environments allow everybody to, let's say, log in and access big amount of data, access high computing performance, and being able to derive your application. In this case, again, I want to stress the idea that these environments are collaborative environments in which through the fast access to data lakes, we can collaborate in our team, as you are doing in this hackathon, to implement innovative solutions using models, notebooks, and any kind of code that you might have developed and that you can deploy. This is, again, the schematic of the Blue Cloud environment. And so you have, sorry, it's not displayed properly, but you have in the material of the hackathon access to all the VLabs resources and the workbenches. So from the workbenches, you have a lot of data that you can access, and which variables, for example, here is just a schematic from the Copernicus Marine Service that tackles ocean health and suggests oxygen, nutrient, acidity, chlorophyll A, transparency, turbidity, salinity, temperature, and ocean currents as key variables, to tackle ocean health challenges. And plus, we have heard that Blue Cloud provides fishery data. Jean-Olivier just presented phytoplankton and zooplankton workbench and other resources to tackle this kind of data and to model this kind of data distribution. And I want to leave you with this paper from Friedman et al. 2020, whose title is Research Priority for Achieving Healthy Marine Ecosystem and Human Communities in a Changing Climate. They identify 9 priority research areas and 46 research questions. And for the ecological analysis, these are the main questions identified. So you can read them. At what point will there be tipping points in ocean circulation? What are the projected local and global implications? How will climate tipping points affect ocean health and people? What does the possible ocean future look like? what are the range of possible outcomes, what are the future uses of ocean, and so on. So please read it carefully. These are questions that can inspire you and I think also can help you to, let's say, shape your deliverable for the final evaluation of your project. To conclude, my suggestion, so adopt a collaborative and transdisciplinary approach to tackle complex problems. So your team should have, technical skills into it, but also data knowledge and model. And let's say this is a big advantage. The present data landscape allows you to access a wide amount of ready-to-use data. Please explore them. We need to use as much as data as possible to drive our application to be reliable and to, let's say, reduce the uncertainties. And another point is take care about the data quality that you use and validate your final results. So good luck, and I'll be available to discuss your project with you.
Thank you very much, Simona. Thank you again. A very good presentation, and you touched upon a variety of topics that are important to the community. You discussed the FAIR principle, the collaborative aspect, the quality of data. It's all super important and something that our participants should keep in mind. It's going to make their deliverables a lot more qualitative and probably get them some extra points. So we have now heard from our three lead mentors for challenges 1, 2, and 3. And we do already have a couple of questions that we will be replying to at the end during the Q&A session. We are now quite excited. Thank you so much, Simona, and we're very happy now to introduce to you the team that is going to be supporting you for challenge number 4, which is our wildcard, where you are going to be able to use the digital twin of the ocean. Your lead mentor for this challenge is going to be our colleague Julia Vera from Seascape, Belgium. Hello, Julia. Julia will be supported by our colleagues from the EDITO team. We have Felix Dols with us here. Hi, Felix, thank you also for being here. And Julia, I'm going to let you get on to your presentation, and we're going to talk right after that.
Thank you very much, Angeliki. So hello, everyone. My name is Julia Vera. I work for Seascape Belgium. And as Angeliki has said, I'm here to introduce you to Challenge 4 of the Blue Cloud Hackathon. So first of all, I want to give a high five to my colleagues Angeliki and Schickele for all the hard work that they've been doing to bring us together. They've been, I have to say, working very hard in the last months to make this hackathon a great experience for you, but also a useful and a productive event for everyone who's involved in Blue Cloud, and they're doing a great job. So thank you for that. Of course, also thank you very much to you. Big thanks for your participation, as well as to all the Blue Cloud colleagues who are, I have to say, very generously sharing their time and knowledge to guide you through this event. So having said this, let's jump into Challenge 4 of the hackathon. Challenge 4, as you know, is the wildcard. And I think it is fair to say that in this challenge, the term wild takes on its full meaning, because in this challenge, we're going to invite you to use Blue Cloud resources, but in combination with resources that are offered by EDITO, which is the public infrastructure of the European Digital Twin Ocean. So as it is not challenging enough to navigate a new platform, we're asking you to actually work with 2 different platforms. So that's wild enough, I think. But there's actually a very good reason why we're inviting you to do that, as I will explain. You've heard a lot about Blue Cloud in the past couple of weeks, but you're probably wondering, what is EDITO, and also maybe what does Blue Cloud have to do with it? So I want to take 5 to 6 minutes to explain what we're inviting you to team up with EDITO during this hackathon. And then, as Angeliki has mentioned, I will give the floor to my colleagues, Jerome, Gasperi, from Mercator Ocean International and to Felix Dols from Deltares, so that they can dig a bit further into EDITO and tell you a bit more about this exciting platform, explain what is it that it can actually do for you, but also how it is already being used by ocean researchers to address ocean challenges today. So why EDITO? As I said before, EDITO is the public backbone infrastructure of the European Digital Twin Ocean. You might know that about 3 years ago, President von der Leyen, she's the president of the European Commission, she announced that Europe would build the European Digital Twin Ocean to make ocean information openly available to all. At the time, her announcement was met with a lot of expectation, but the truth is that the idea of working with digital twins, harnessing ocean data, models, artificial intelligence, to advance our knowledge of the ocean and to make it more, let's say, rapidly accessible, has been going around for quite a while. Blue Cloud and many other projects have been piloting ideas, we could say, for over a decade. There's a wealth of projects that have been making very significant contributions to accelerate ocean knowledge. And in the last couple of weeks, you've heard already about many of the services that are available in Blue Cloud, which have been co-created by scientists precisely to do that, right? To deliver ocean information faster. In fact, I think it is fair to say that in Europe, we've had the key ingredients that are needed to harness the power of digital twins of the ocean for quite a while. And my colleague Simona has touched on this in her presentation as well. We have a strong ocean observing system that gathers millions of satellite and in situ ocean observations. We also have very good operational services, marine data services like Copernicus Marine, like EMODNet, which make much of the data that is derived from these observations publicly available to all, to advance research and innovation. And we also have a thriving network of researchers, of environmental modelers, data scientists, software developers that work to transform that data into knowledge. And the colleagues who are working in the Blue Cloud project are a great example of this talent and capacity, but there are many, many more in Europe and beyond who are also involved across many different projects and initiatives in generating new ocean knowledge, right? But it is also fair to say that at the time of von der Leyen's announcement, we could argue that Europe was still maybe missing one key ingredient that is really needed to really enable and speed up the development of digital twins of the ocean. And that's long-term infrastructure that can connect all of these different elements together, bring all of these actors together into a single digital framework, so that the research and innovation community, people like you, in collaboration with societal actors, can join forces and come together to jointly address specific ocean challenges together. And that is exactly what EDITO is. That's the type of infrastructure and the platform that EDITO is bringing to the community, that is bringing to you. It's a platform that offers access to world-class ocean data and resources that you can use to build digital twins. And it is not just any data, but data from trusted services, from services like EMODNet, like Copernicus Marine Service. But even more importantly, it's also a platform where the community can come together to share their own data, their own models, their own applications, so that together we can create this European Digital Twin Ocean. So EDITO has been set up by the European Commission with the ambition of having a long-term infrastructure that can support a thriving ecosystem of digital twins and applications that can share resources, that can speak to each other, and that can therefore provide science-based answers to ocean challenges. So I guess you might be asking, this is all very nice, right? But you're probably asking yourself, so how is this all connected to Blue Cloud? And I would say that projects like Blue Cloud are very important. First of all, because they show what the scientific community can achieve when open science leads the way, but also because they can make great contributions to the co-construction of the European Digital Twin Ocean. And as a matter of fact, there are ongoing discussions between EDITO and Blue Cloud already today, as well as with many other projects and initiatives, to see how we can collaborate and work together, federate resources, so that we can co-create a single environment. That's the European Digital Twin Ocean, a single environment that makes it easier for everyone to find the tools, the information that you need to address or to be informed about ocean challenges. And we're not exactly there yet, but this is the ambition and this is the direction in which we're going. So hopefully in a few years from now, you will be able to access Blue Cloud resources and EDITO resources through a single access point without having to worry about working with different environments. They will be seamlessly interoperable. That's our vision today. And although this is not yet a reality, we would like you to get a feel for the potential of this combined power. And so we want to challenge you to reach both platforms, to already show what is it that you can do with these resources. And that is, I would say, what Challenge 4 is about. So as you can see, very different from the other three challenges. But a nice thing about Challenge 4 is that there are no limits, there are no constraints to the ocean topic that you might wish to address. This challenge is about showing how you can tap on Blue Cloud, tap on EDITO, tap on both platforms to address any ocean challenge that is dear and that is important to you. Knowing that EDITO is a long-term infrastructure that is here to stay, and that all the resources that are currently available in Blue Cloud will also find their way into this long-term infrastructure, of which Blue Cloud will also be part. So I hope this is a good introduction to the topic, but I'm now going to hand over to my colleague Jerome for a deeper introduction to the EDITO platform, as I mentioned before. So I think over to you, Jerome.
Yeah. So thank you. Do you hear me, everybody? Perfect. So first of all, thank you, Julia, for this very clear and complete introduction. Do you see my screen?
Yes.
Okay, perfect. So I will not comment this slide because it's already said by Julia. So directly to say what is EDITO in a concrete way for this hackathon. So EDITO, it's a place where a platform where you have data and models, computing resources that are both GPU and CPU, services and on-demand processing. So everything on the same platform. And it's based on 3 pillars, which is the explore, create, and contribute. So basically, the explore is just to visualize all the product, the service, and the application you have on the EDITO platform. And create is about using the resources provided by EDITO to create your own service or application. And contribute, it's a step further. It's this application you develop to be able to share to the community. So what you see from the outside of the EDITO, if you don't go in the root of the platform, is that you have a viewer part where you can visualize all the product, and you have what we call the data lab, which is basically the center from where you can access your resources, your data, and where you can launch, create, and access your application and services. So on the storage part, EDITO has a data lake. This data lake, it provides you a catalog and a data storage. So the catalog is basically the index of all the data that are stored on the data storage. So data storage is an object storage. So it's basically S3 API on top of it. And on EDITO, you have the core data that are available on EDITO are the Copernicus Marine data from the Copernicus Marine service. and the EMODNet data, which are the in-situ data from the European Commission. And the Copernicus marine data are basically marine forecast and marine physical data that are available in what we call ARCO format, which is analysis ready cloud optimized format. So basically it's ZAR, meaning that you can easily work on it in a very fast way. So because it's optimized for cloud computing. On top of that, you have the catalog. So basically, this is the index to find all this data, and it's it's conformed to the search API of Stack, which is a spatio-temporal asset catalog. And basically, you can search, retrieve, and publish data on this catalog. Next, we have the EDITO engine. So EDITO engine is based, you have a catalog of services and of processes, which is linked to the computing cluster, the EDITO platform, but also can be linked to HPC, in particular to the Euro HPC, meaning that from EDITO, you can, if you have an account on one of the Euro HPC, you can basically launch process, trigger process from EDITO to this HPC, thanks notably to a Jupyter auto-submit service, which is pre-configured to connect to Euro HPC. So here we introduce two concepts, which are processes and services. So processes are basically temporary operation, like you put input, you launch the process, and you have an output. And a contrario, service is more a permanent application, so you can access it at a given URL. And this, we have two kind of services. We have the services like the Jupyter notebooks, we can be seen as temporary services, meaning that you launch your Jupyter notebook, you work on it, and when it's finished, you close it, so it's not available anymore. And application like if you develop a what if application, you want it to be available 24 hours a day and to a given URL, which is what we call the permanent application. So the onboarding on EDITO. So the first thing you have to do is to join EDITO. So on this, you go to edito.eu and you click on join EDITO if it's not already done. Then you will be able to create an account. And once your account is created, you have access to the EDITO platform, which is basically the data lab. On the data lab, once you create an account, you have zero resource, meaning you cannot launch anything. So you have to specifically ask for resources. So you can click on ask for resources, and you have a form to complete, and then you express what you want in terms of resources. In the resources, you can access CPUs, but you can ask also for access to GPUs if you need for your challenge. So once you register to the data lab, so basically the data lab, when you will arrive on that, it's you have a project switcher at the top. So by default, you are in one project, which is your own project, and so it's your username personal project, and then you have your services, your processes, and your file explorer, and all resources that you can see on the left bar are related to the project you are. So it means that if you go to another project, because for the hackathon, we can imagine we set up a project for you called Blue Cloud and No, then you will if you go to the Blue Cloud project, the my service, my processes, and file explorer will be related to the Blue Cloud and not to your personal project. And the service catalog, basically, as I explained, you have already plenty of service you can launch. So basically, you have the Jupyter Lab, Air Studio, AutoSubmit, and so on. You have a viewer like Stack Browser or other application. You have the What If application. You have a Nemo process also if you want to do modeling. And the data storage, which is a focus on it. So to push your data, you can do it from the data lab. So you go to File Explorer, and then you have access to your S3 bucket, and you can just upload data, like drag and drop data on this page. And in each data you will upload, you see an eye on the right, and if the eye is closed, it means that it's private. And when you click on it to make it open, you have access to a public HTTPS endpoint. So it's a way to put it in the public. This, of course, you can do it through the command line. So From the command line, you first need to install either AWS command line or MC, for instance, which is my new command line. You go to your homepage data lab, and from here you will have your storage credentials that are automatically private and public and private keys that are done for you in the data lab. And you have example of code to access your storage either through Python, R, whatever, or from the command line. So here, for instance, I show you how to use the command line. You just have to export to MC host S3 that you can copy from the data lab. And then you can, through a command line, just copy a local file to the destination file. You can put it publicly available just by command line. And then after that, you will have your file available if you want to share it to other people. On the application deployment, in this hackathon, we want the previous way to deploy application. I think this will be shown by in the next presentation. You have to write YAML file and so on to deploy, but we are working on a very easy one-click deployment application. So basically, you just need to have a GitHub or GitLab somewhere, either a HTML document or a Docker file, and just by giving this URL and go to the right application, the EDITO engine will automatically build the application and deploy it. So it's really simplifies the process deployment, and so you just have to focus on your development and not on the deployment on EDITO. For instance, if you want to deploy an application from an HTML file, you search for the static pages services in the service catalog. And then when you click on it, you will see you just have to point to a GitHub repository or to a HTML file somewhere that is available from a URL. And from this, EDITO will automatically embed that into a web service and launch your service on a URL. So you can see the example here. I give you a dummy hello world index.html repository, so you can try it. And if you want to deploy an application from a Docker file, it's more or less the same, but then you search for another service, which is called service contribution within the data lab processes catalog. And then you just have to point to your GitHub repository with your Docker file. You launch a process, and then the image will be automatically built and add as a new service in the service catalog. So now when you go to the service catalog and you search for your image, you will see it and you just can launch it. So launching it means you click on launch, you select the number of CPU you want and the RAM you want to launch the services, and it will appear on the URL. One important thing is that this application deployment from a Docker file, it's not available right now for publicly. So if you need it in the frame of this hackathon, you just have to contact us and we will give you access to this application deployment. The previous one with HTML, the static page is available publicly. So this you can use without any restriction. That's all for me. Thank you.
Thank you so much, Jerome. We'll go to Felix.
How much time do we have? Because we already scheduled at the end. I can go through it a bit quicker.
No. We have some time. Please go ahead. Take your time.
Also use the different camera, otherwise you see my forehead only. Screen. I guess you can see my screen now.
Not yet. Great. Yes. Now? Yes.
Okay. I will represent the perspective of EDITO Model Lab. Basically, we have been, for the past 2.5 years, the pre-beta users and contributors to the EDITO platform. And as Jerome said, we've been creating some services, which was sometimes a bit more complicated than it will be for you. So lucky you. But we hope to share a perspective that comes a bit closer to the people that want to join Challenge 4, namely the perspective of a researcher that wants to share his work on EDITO. To use these different components of the EDITO platform, one is that there is a data lake which you can use, and these slides will be shared, so you don't have to retype it. A data lake on which you can leverage with your applications, and we're adding data to it, and also you could add data to the EDITO data lake. And there's also a huge amount of models. Now already available are models for ocean and coastal hydrodynamics, models for biodiversity, for ship routing, and for simulating oil spills, for simulating the transportation of microplastics. And we're also adding reduced physics models and even statistical models for faster computation. They are turned into services, as Jerome said. So here, there's a screen where you can launch some of these services, and we will show a use case later on. When you have been granted access, you can run them, your service or your process on the cloud. But there's also ways of connecting to HPC resources like the cluster here in Barcelona, if you want to run larger jobs. And there's a way of on-demand processing. So that is a way of to visualize. You can set up a model for some applications anywhere in the world. Some of the application areas that Model Lab has focused on is biodiversity, is zero carbon, and then ship routing to reduce carbon emissions, and the goal of zero pollution and oil spill hazard mapping and trajectory mapping. There's tutorials on how to use these applications on the EDITO platform. You can go to, if you're logged into the data lab, you can go to trainings and tutorials, and here's just one example on the ship routing applications where there's a bit of scientific background, then some screenshots and explanation on how to launch it, how to use it, and what kind of data you can expect that you are creating. And in the end, some more in-depth scientific background on for if you want to really understand what's going on in your application. I will talk a bit more about the application that we developed, and that's on marine protected areas for biodiversity. And what we did is habitat suitability modeling, relocatable, but we have an example for I think Vietnam and the Wadden Sea. So we used a couple of different components that are available on the EDITO platform. So this can all be done by you as well if you follow the tutorial. So we used the hydrodynamic model and a post-processing model for ecological impact for the habitat suitability computation. We used data from both EMODnet and from CMEMS to set up this model. We ran it on the cloud, on the EDITO resources, and we use services to set up the model and to visualize the results. And the idea of this all is that it can be relocatable to any location. The user decides where to set it up, and the data is loaded, if not in Europe, then from a different source for bathymetry. So it works in this way. We create spatial maps of environmental conditions, for example, with a numerical physical model like Delv3D, but it can be with any source that creates netcdf files. Then for every spatial cell, we compute the suitability for a certain habitat species like seagrass or a mussel or shellfish that is crucial to an ecosystem. For every cell, we compute the suitability for that species. And then we get maps like this, where all the blue and green is just zero suitability for a seagrass in this case. And all the white to red is a certain degree of suitability for this species to grow. And that's done by another process that can be launched on the EDITO platform. So to launch the first service to set up a model, we will show a video. You can find it on the data lab, and you can choose some of the inputs like credentials, because we're gonna in the service automatically download some of the inputs, and that is saved in a credentials file. So once you have set that up, how to enter the climate data store and CMEMS, it's optimized. And so now we launch the service, and it opens a notebook environment where step by step you can name your model. You can choose if it's 2D or 3D. You can choose a domain. And this one is optimized for when we call it Vietnam, and we can choose a date for which to run it. And so you're very well invited to recreate this data, but also for different areas that are of your interest. And then step by step data is loaded for setting up the model. So boundary conditions, atmospheric conditions, that step by step are loaded, and you can see what kind of data you are loading. Then we create some observational files. They are also visualized here. And this is specific for a model run with Delta3D, but there's also a way to set up a model with, for example, Nemo or with Schism. Then you see what kind of files are created. So now created a bunch of files, but that is what we need to run on the cloud without any installations or hydrodynamic model. So here it's now copied to your personal storage on the data lab. And this model or this set of files, and now we can launch Delta3D, which is in a Docker container. We can choose our resources when it's allocated to us. And you can also reprogram things, but sometimes it's easier to use the bars. And you can monitor what is going on. So container started, and more information will pop up. And here there's a simple README. And you can also monitor when you run different services, how much of your resources you are using. We fast forward a couple of minutes, and then our run was successful. We get some outputs, and in the map file, there are spatial data for this area of Vietnam that we decided we wanted. We wanted a modular workflow, so you can use parts of it. And so we build a model, then we run a hydrodynamic model to create spatial data. And the next step would be to define the ecological knowledge rules, and we have a service for that as well. And then to run a post-processing tool and to create these habitat suitability maps. And then we have a service to visualize. And what we also want to show is that you can replace or you can add other spatial data fields by, for example, using, oh, this goes without clicking, by, for example, using an AI trained model that is from another partner. It's called 4D-VARNet from IMT Atlantic. And here in this video, we want to show you how to launch that for a preset area in the Wadden Sea to generate turbidity fields, which are quite computationally intense. And so we generate it based on satellite data rather than physically simulating it. So we open a different service here. And once you launch it, you can open again a Jupyter notebook. And then here it's already run, but step by step, you load data, and you load your pre-trained model. And you also have some benchmarking statistical analysis. So on the left top, there was GAPI data from one of the days that we simulated from the satellites. we mask with the artificial clouds. So I go, we mask with artificial clouds. And then there's 2 benchmarking techniques, and there's the 44net results in which the gaps are filled for this specific days in order to visualize what we've done. So there's different layers, as already said, in how you're encouraged and allowed to interact with the EDITO platform. You can explore by redoing the work that's already done, or by looking into the viewers of the data lake. You can contribute by adding data, running it for new scenarios, or by building your own service using components or adding components. And you can create a whole third-party service as well, but that might be a bit far-fetched for only 3-day hackathon. There are some resources. I want to share this PowerPoint, so this could be useful. I will also share it in the notes or in the chats of this Zoom call. And basically, we will support you as Jerome from the perspective of the developer of the platform, and I will support you with my team from the perspective of first data users, share our experience, and hopefully you become happy using it. So that'll be it from my side.
Thank you so much, Felix. Again, another very important perspective. So for this challenge, we've heard from Julia in the very beginning, who presented us indeed with a wonderful vision of what we look forward for in the future, and that our amazing technical team at EDITO is working on actually fulfilling. As Felix just mentioned, you're going to have a lot of support for this challenge as well. The tools, both the Blue Cloud tools and EDITO, it would be very good if you could try and familiarize yourselves with all of them ahead of the hackathon. Use this weekend that you have in order to do so. We are very happy to announce that we are launching the Hack Pack tomorrow early on, and we're going to, of course, let you all know on Discord. If all the lead mentors and their team could now turn on their cameras. Thank you so much. Again, I hope that this has been, I believe this has been very useful to all participants for all challenges. As you can see, there's a lot of technical knowledge behind every team. They are working on creating these tools for you. You're going to be lucky that you're going to be using some really new tools. One of them, Jerome Gasperi mentioned also in his presentations. You can request a special access for this if you feel that you're going to be needing it. We are going to take a look at, we have a question, I believe it is for challenge 2 for now. So perhaps Cyrielle, we are going to look to you. But if anyone else would like to supply something additional, very welcome. So the question is the following. In challenge 2, if we aim to develop a product which is primarily reliant on Copernicus and ERA 5 datasets for its UI support in the current prototype, and provide a plan and structure for future integration with comparable Blue Cloud resources, is that a valid and acceptable solution, or are we risking loss of points by not integrating as many Blue Cloud resources as possible? Our reason for this, approaching it this way, is that due to the complexity and layers of our solution, it would be helpful to have usable UI interfaces and support from the dataset providers, which we were having a hard time obtaining from existing Blue Cloud resources. So, Cyrielle, if you would like, and then yes, I think that we can all supply a little bit more context for this.
Yes, thank you, Angeliki. Well, I think it sounds like a great idea, the idea they have. I would still be interested to know if we can help them further, maybe with that Blue Cloud user interface that they've been having issues with. Because I think the more Blue Cloud resources they use is probably the best for this hackathon, especially because we have this criteria of minimum 2 VLABs or workbenches, if I'm right. So yes, but obviously if they provide a plan for future integration, that's also very interesting. So we can definitely talk about it, but they do have to meet that criteria of 2 VLABs and workbenches.
Absolutely. Thank you. Thank you very much. That indeed is part of the purpose that we've been discussing also in the last couple of weeks during these sessions. We want you to use the Blue Cloud resources. We look forward to your feedback. There's a lot of work going on in the background, continuously improving them. However, as Cyrielle said, there are alternatives that will be acceptable. And again, you can connect with Cyrielle and maybe provide her with a little bit more context on what it is that you're trying to create. Having said that, of course, keep in mind that indeed points do go for the most usage of Blue Cloud resources. And of course, also if you're taking on Challenge 4, the usage of all the EDITO resources. Simona, please.
Yeah, just giving some suggestion because they are also asking for help, you know, on the data. But I think that both Blue Cloud, but also from the EDITO presentation, what we serve are data optimized for the cloud environment. So actually the advantage of this kind of services is to have faster access to the data. So of course we have coach and mentors that can help, but I don't see these as a limitation in the application. And both the Copernicus data, for example, are available from the physics workbench, the in situ data. But from EDITO, there are all models available. So actually, you are maybe looking at challenge 2, but maybe challenge 4 is also another option that can facilitate. And as far as I remember, I think that yesterday Robin was also presenting that Beacon is having an instance of ERA 5 data to query, and maybe you want to look at the Beacon webpage and the GitHub for some example notebooks. So yeah, I don't see big limitation on this project. So just get in touch with the people, the expert to.
Thank you. Thank you. Yes, indeed, Simona, you're right. We did have a good presentation on Beacon and it was mentioned. And again, as you can see, the interoperability part that this community is working on is becoming quite a reality. There are a variety of different data sets and tools that you can use. I have to say, as Simona mentioned, you might want to take a look at the possibility of working with Challenge 4. Indeed, there's a wildcard and maybe the resources you want would be all there present. So let's see.
I just maybe wanted to jump in for a second, Angeliki, and share my screen with the hack guide. So going back to the question that we received for challenge number 2, one of the key part of the deliverable number 2 is the feedback on Blue Cloud services. So maybe under here, ideas for improving Blue Cloud, then in there you can maybe provide your idea for more clear UI interfaces and so on. Because if we go to the evaluation criteria, if we go down here, then you will see that we will give you 5 points for the clear feedback on Blue Cloud services. So that is, I mean, we understand that, but you can also gain points from this situation if you provide a clear feedback. That's the only thing that I wanted to say.
Indeed. Thank you. Thank you, Michela. This is then very clear, I hope. I do not see any additional questions today. Of course, again, we will be available on Discord. So tomorrow is going to be a big day for Blue Cloud Hackathon participants. We are going to be sharing the hack pack. We're going to be opening officially the channels, so you can already start working on your ideas. Take a look at the resources. There's a lot of material to go through. We are trying to keep things in good order so that you are not obliged to, of course, go through too much documentation, but still there are a lot of tools available for very good solutions. I don't know if any one of our lead mentors and presenters would like to say anything before we go, but we look forward to beginning this hackathon. As Julia mentioned, there are so many people who have already worked a lot on it. We are quite excited. The participation seems to be going very well. We expect solutions not only from Europe, from around the world. And if we don't have any more questions, we are going to leave it at this. We are going to let you go. Again, go ahead, explore, please explore the resources. Be alert tomorrow for when we will be launching the Hack Pack, which is going to be your guide through this whole process. And I would also like to take the opportunity to finally mention that for those of you, once again, who are taking on Challenge 2, we have already sent you an email today. We are asking you to identify the people who are going to be working on EDITO so that we can fully prepare for having you on board immediately when the hackathon launches. Thank you all very much for your work so far. Thank you very much also for what is going to be coming next week. We have a lot of participants. We have so many teams joining us. We're very happy about it, and we understand it will be a lot of work for you. So again, thank you ahead of time.
I will
Michele
share
will now
maybe,
take you.
yes, I will now share the plan for next week, the official plan. So I'm going to take you 1 minute. So basically next week we will kick off the hackathon officially, 10 a.m. on the 29th of September. You will receive all the details via email. I'm going to send you an email from Event Tornado, so you will have the Zoom link there. We will not send you a calendar as we did for these live sessions. So you will need to check your email for this. And the same is going to happen for the final pitch and award ceremony on the 2nd of October, starting from 3 CEST. All the times are in Central European time. Same, I will send you a link to join the pitch and award ceremony via Zoom. And yes, so next step would be, as Angeliki said, to thank you all. And you can find us on Discord. Again, Discord will be the only way that we will support you, the only communication tool. And so see you all there. All the mentors and coaches are already there.
Thank you, everyone, very much. Thank you so much. Looking forward. Happy
Thank
hacking.
you.
Bye.
Bye.
Bye-bye.
Thank you. Good luck.